Okay, this chapter that we're going to start is all about sequences and series. When you first learned about sequences, we'll be in elementary school, where, let's say they did like a circle, square, triangle, then they would do a circle and they would say what comes next. Or you do like an apple, orange, banana, apple, orange, and then they'd want you to know that banana should come next. Then you started doing like with counting numbers, like you go 2, 4, 6, they'd want to know what the next one was. Well, you knew you were counting by twos, so you could figure it out. So a sequence, as we're going to talk about it, is just going to be a list of terms. And we're going to do numbers. So we're past where you do your fruits and different shapes. So everything will be numbers. So a sequence, that's just listing them out. A series is when you're going to find the sum of them. So you're going to take all of those and you would add them together. Okay, factorials. Only other time we really talk about factorials is when you do probability. You have a factorial. This is your exclamation point. You have that on your calculator. And if you're using a calculator like the ones I have in class, it is underneath PRB, and you would scroll over, it's the third thing. PRB is diagonal from the second button. Depending on what calculator you use, could be in a different spot. Okay, and then we're going to talk about in factorials, when you're multiplying, let's say it's like 4 factorial, that's 1 times 2 times 3 times 4. It's everything multiplied up to that number. Or you can think of it from that number down to 1. And then we're going to talk about summation notation, or sigma. This is the Greek letter sigma. Okay, it stands for sum, so you're going to be adding things together. This part right here, this is like your equation. And then when you're going to find the number down here, this is like you would plug in to find your first term. And then we'll talk about, you'll go all the way up until like this number would be your last term. So if you're trying to find all of them, you would like plug this in. So like let's say this was 1 and this was 5, you would plug in 1, 2, 3, 4, and 5 all into this equation, and then you would add those all together. It's just a different way of finding the sum, is they try to condense it down into sigmas. So today's lesson is just about general sequences and series. Tomorrow will be about, I call them arithmetic or arithmetic, whatever word you want to use. That's when, to find the next number, you're always adding or subtracting. And then the following day, you will do geometric, and that's when you're multiplying. Geometric also have infinite ones that go on forever. Arithmetic, they do and don't. We'll talk about that a little bit, but basically the only ones you have to focus on for infinite would be geometric. So this today is just generic things. Okay? So first thing we're going to do is we're going to find the first 5 terms of the sequence. And it says that assume that n begins with 1. So if and I'm just going to label, it's always going to be a n. A of n just means that's like your equation. Okay, it's kind of like y equals when we talk about linear functions. So if I want to find the first terms, I want to find a1, a2, a3, a4, and a5. How you find these numbers is you just plug in the number. So it says, assume it begins with 1, that's where we're starting with a1. We just plug 1 into this equation and solve. So 1 times 5 is 5, minus 3 is 2. Then I plug in 2 to find my second term. 5 times 2 is 10, minus 3, 7. Find the third term, I plug in 3. 5 times 3 is 15, minus 3, 12. Okay, find the fourth term, you plug in 4. 5 times 4 is 20, minus 3, 17. Find the fifth term, plug in 5. 5 times 5 is 25, minus 3 is 22. Okay, if it said n begins with 0, then you would plug in 0 would be your first number. You'd find A0, then A1, then A2, A3, etc. Okay, so that's all this means is whatever it tells you, that's what number you're going to start with on your sequence. Okay, so we're going to do the same thing on number 2. So I'm going to find the first 5 terms. So if I want to find A1, I'm going to plug 1 in for n. So 1 plus 2 is 3. And I also have to plug 1 in for that n. So 1 plus 2 is 3 divided by the 1 is 3. Find A2, plug in 2. 2 plus 2 is 4, divided by 2 is 2. Find A3. 3 plus 2 is 5, divided by 3, 5/3. Or if you want to put it as a mixed number, 1 and 2/3, that's fine. Find A4. 4 plus 2 is 6, 6 divided by 4. Okay, I want you to reduce that either to 3/2 or 1.5. And then A5. 5 plus 2 is 7, divided by 5, 7/5. Okay, if you have a problem that doesn't have a variable in it, so like this one is just A and it's 2/3. That means my first term is 2/3, my second term is 2/3, my third term, etc. If you don't have a variable, you can't plug numbers in. That means everything in the sequence is the exact same answer. So every answer is going to be 2/3. Okay, so it's not like a trick question, that's just how you solve it. Okay, and then you're on ones that have exponents and have factorials. Okay, so if I want to find A1, I'm going to plug in 1. 3 to the first is 3. Then if I find 1 factorial, that's just 1 times itself. So 3 divided by 1 is 3. Okay, if I want to find A2, 3 squared is 9. Okay, 2 factorial, that's 2 times 1, which is 2. So this would be 9 divided by 2. Okay, if you want to put 4.5, that's fine. Okay, find A3. Okay, 3 to the third is 27. And then 3 factorial, that'd be 3 times 2 times 1, so that's 6. And if you just want to use the buttons on your calculator, you don't have to do it in your head. Okay? So 27 divided by 6, well those are both divisible by 3. So that's 9/2. That's okay that these are the same number. Okay? I'm not going to do this in my head. Okay, so that is 3 to the 4th, which is 81, divided by 24, because that's what 4 factorial is. Okay, that will reduce, because they're both divisible by 3, to 27/8. Okay, or you can do it as 3 3/8. Okay, and then 5, 3 to the 5th is 243. 5 factorial is 120. So if I divide those out, this would be 81/40. And if you want to write it as a mixed number, that's fine. Okay, next thing is you're just going to find the indicated term. It's going to tell you what you're plugging in. So this one says, I'm going to find A25. That means you're going to plug 25 in for your n and solve. If there's multiple n's, just like we did on these first 4, plug them in for all the n's. So this would be -1 to the 25th times, and I have 3 times 25, and then I'm going to subtract 2. Okay, follow your order of operations. So -1 to the 25th is -1, and then I'm going to multiply that. Well, 3 times 25 is 75, minus 2 is 73. So if I multiply those two together, I would have -73. Okay, so all of those are just plugging in numbers, always plugging them in for the variable, which will almost always be n. Okay, sometimes I use different ones, but most of the time it is n. Okay, this next part is probably the hardest thing, I think, whenever you're trying to solve, because there's no like set formula. So what you're trying to do is you're trying to write an expression, okay, which I'm going to make them equations, but you're trying to find something that would work. So what you're trying to do is you're trying to come up with these equations that you were given. So you're working backwards from the answer and trying to come up with the equation. Okay, there's no, like, this is always what's going to work. What I try to do is I try to say, okay, I try to think of multiplying first. So I'm like, okay, well, what if I did, all right, let's just say if I did 1n, okay? All right, well, if I plug in 1, then I get 1. But if I want to find my second term, I plug in 2, I only get 2, and I need to get 4. So that's not going to work. So then I think, okay, well, now I go to my next thing. I'm going to try 2n. So if I try 2n, well, if I want to get 1, I plug in 1, I get 2. To order to 1, I would subtract 1. Okay, so let's see if that works. So plug in 1, 2 times 1 is 2, minus 1 is 1, so my first term's right. Okay, then I check my second term, so I plug in 2. 2 times 2 is 4, minus 1 is 3, but my second term should be 4. So then I know it's not 2n, so then I go check the next one. So now I'm going to try 3n. Okay, well, if I want to get 1 and I plug in, so 3 times 1 is 3, that means I would have to subtract 2 to get my first term. Okay, so let's see if it works for the next one. So I plug in 2, 3 times 2 is 6, minus 2 is 4. Okay, so it works so far. Has to work for every number that you're given. So let's try 3. 3 times 3 is 9, minus 2 is 7. Okay, that works. So plug in 4. 3 times 4 is 12, minus 2 is 10. We're good? And then 5. 3 times 5 is 15, minus 2 is 13. So this is my equation. Okay, this works if you see that the numbers are kind of going up by the same amount. If you see numbers that are going up really high quickly, you're probably dealing with an exponent or a factorial. Okay, so if I look at number 7, I'm starting with 1, and then I go to 1/4, 1/9, 1/16, 1/25. Well, if I change this to look like the other ones, this would be like 1/1. These numbers on the bottom are going up a lot faster than just adding 3 every single time. So I know this is either going to be something with an exponent or it's going to be something with a factorial. Okay, but if I look at the top, every single time on the top, I get the same answer. My answer is 1. So I'm done with the top, so now I got to figure out what's going on in the bottom. So I would just try squaring first before you try factorials. So let's just see if I can just do n squared. Sometimes you have to do like n squared plus 1 or n squared minus 2. So if I plug in 1, 1 squared is 1, 1 divided by 1, okay, that's good, that's my first term. See if it works for the second term, so I plug in 2. 2 squared is 4, 1 divided by 4, 1/4. See if it works for the rest. 3 squared is 9, we're good. 4 squared, so then that's my equation. Okay, then the last one, I want to do an example of this. If you're alternating negatives to positives, regardless if you're going 1 to -1, if you're going 2 to -2, or 3 to -3, if you notice that they're alternating every single time from positive to negative, that means you need to have a -1, and it's either going to be to the n power or to the n+1. Depends on if you're starting out positive or negative first. After that, if there's other stuff going on, then you would just multiply it by that. That's what was going on up here. This means every other term would go positive to negative because of this part here. This is the rest of the equation. So if I'm just doing once, I need to know, okay, this is going to be positive first. So if I do positive, I plug in 1, this gives me -1, so that means this isn't going to work. If I want positive first, that means I'm going to have +1. Because even exponents make negatives positive. Okay, and I definitely think this is the hardest stuff that you have to do on any assignment, is trying to come up with the equations. Okay, I'm going to erase this and put the next stuff up here. Okay, so I know this last one's kind of hard to see, so I'll talk about it when we get there. Okay, defined recursively. That means when you want to find something that's defined recursively, you're going to plug in the previous term. Okay? So it says find the first 5 terms of the sequence defined recursively. Well, I'm given A1. So I know A1 is 28. When I want to find A2, instead of plugging 2 into the equation, defined recursively means you plug in the previous answer. So I'm going to plug 28 in up here. So 28 minus 4 is 24. Then when I want to find A3, AK means you plug it in the previous one. So I plug in 24. 24 minus 4 is 20. So defined recursively means you're plugging in the previous problem into that equation that they give you. So A4, plug in 20. 20 minus 4 is 16. When I find A5, plug in 16. 16 minus 4 is 12. Okay, they're always going to give you at least the first term to start out with. They might give you more than one term. So if you're trying to find the first 5, they're going to give you the first one. They have to in order to be able to do it recursively. Okay, simplify the factorial. Number ones, if you want to do them on your calculator, you don't want to do them in your head, that's totally fine. When you get to the variable ones, though, there's no way of doing those on the calculator. Okay, so I'm going to show you the process of doing the number ones by hand, because that's the same process we're going to use on the variables. So if I want to do 4 factorial, that's 1 times 2 times 3 times 4. And if I want to do 6 factorial, that's 1 times 2 times 3 times 4 times 5 times 6. Okay, then I like to see what can I cancel. Well, top and bottom both have 1 through 4, so I can cancel those. I'm left with a 1 on top, and then I have 5 times 6 on bottom, so my answer would be 1 over 30. Okay, same process goes with variables. So if you want to think of what is n plus 1 factorial, well, I had to eventually start with a 1, and then I had to go to a 2, and then eventually you're getting to the point where, okay, how did I get to n plus 1? Well, I would have gone to n minus 1, and then the next thing after n minus 1, if I add 1 to that, that would be n, and then I would go to n plus 1. Okay, well, if I'm just going to n on the bottom, I would have the 1 times 2 times 3, etc. I still have my n minus 1. Then I go to n, but I'm stopping. So I look to see what will cancel. All the way up through n cancels, so my answer would just be n plus 1. Okay, now I know that's kind of hard to think about, but you always have to think every time you're going before, that would have been n minus 1, and the number before that would have been n minus 2, and the number before that's n minus 3. When you go forwards, n plus 1, n plus 2, n plus 3, etc. Same is true if you're taking 2n or 3n or 4n. Okay? So like whatever I'm doing, if I keep going, I always start, we don't know what our first numbers are. Okay, but if I want to keep going backwards, this would be like 2n minus 2. And then I have 2n minus 1. Okay, same thing on bottom. So I would add 2n minus 2, then I went to 2n minus 1. Okay, if I add 1 to that, then I'm at 2n, and I add 1 to that, I'm at 2n plus 1. Okay, which is where I needed to finish on this problem. So everything that cancels is up through the 2n minus 1. So I still have my 1 on top, and then on bottom I have 2n and the 2n plus 1. If it helps you, plug in a number for n just to check to see if you're right. Plug it in up here, and then plug it in your answer. If you get the same number, you know you did something right. Alright, then the last of everything else else is dealing with sums, okay? And we're going to be using our sigma notation. So I know I said at the beginning, okay, how do we find it? Well, you start by plugging in the bottom number. So I'm going to start by plugging in 1. I keep going until I've plugged in the top number, which is 5. You don't go until you get an answer of 5. You go until you've plugged in the top number. So if I start with the bottom number, I plug in 1. 2 times 1 is 2, plus 1 is 3. Then I'm going to plug in 2. You always just plug in the integers. So if I plug in 2, 2 times 2 is 1 plus, 2 times 2 is 4 plus 1 is 5. Then I'm going to plug in 3. 2 times 3 is 6 plus 1 is 7. Then I'm going to plug in 4. 2 times 4 is 8 plus 1 is 9. Then I'm going to plug in 5 and I get 11. And then I'm going to stop because the top says the last number we plug in is 5. Okay, then you're going to take all of your answers and you're going to add them together. So if I add these together, we would get 35. Okay, so you start by plugging in the bottom number, you finish by plugging in the top number, you plug all the numbers in between there, and then you add them all together. That's how you find the sum. And this is called a series. Series is when you add them all together. Okay, do the same thing on 14, but this time it says we're going to start by plugging in 0. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Okay, stopping there because it said you're going to stop after you plug in number 4. Okay, not the fourth term, it stops by plugging in the number that's on top. So if I add these all together, that would be 30. Okay, that's called sigma or summation notation, is how these are written. That's how you find your sum. Okay, on 15 and 16, these are going to infinity. How do I know that? My top number is infinity. Okay, you're not really going to go to infinity because it's going to tell you to find the partial sum. Fourth partial sum, you stop after you've plugged in 4 numbers. Third partial sum, you stop after you plugged in 3 numbers. You still start with the number that's on the bottom. So I'm still going to start by plugging in 1. So if I plug in 1, a half to the first is a half times 5 is 5 halves. Okay, then I'm going to plug in 2. Half squared is a fourth times 5 is 5 fourths. Then I'm going to plug in 3. And I get 5 eighths. Then I'm going to plug in 4. And I get 5 sixteenths. Since I just want the fourth partial sum, I'm just going to add the 4 terms that I found together. Okay, now if you want to do it by hand, you would just get a common denominator. I don't want to do it by hand, so. You would get 4 and 11 sixteenths.